Okay, so in the first lecture, we discussed the syllabus that we'll learn in this semester, statistical and numerical method. And in this first lecture, was discuss syllabus module. There are 6 units that we'll learn in this semester. Part of statistical method, unit 1, 2, 3, and 4, 5, 6 is a part of numerical methods. Okay. So first we'll start numerical methods, unit number 5, and then after unit number 6, and then after we'll discuss the statistical concept. Okay. So this topics that was discussed in the last lab, its applications, where it is required, why we learn this concept. So that part that we discussed in the last lab. Okay. And now today we'll start unit number 5. Okay, the first method in this unit, the roots of equations, and there are three various sub method: bisections method, false positions, and Newton-Raphson method. Okay. So first we'll start answer directly. Okay. So here it explains what is meaning of roots of equations. We learn to use the quadratic formula to solve the fx, and the value calculated with these equations are called the roots. Okay. For example, if we have equations as a x square uh, minus 4 is equal to 0, so we can easily identify its roots, that is equal to x is equal to plus or minus 2. Okay, this is our fx. That is a simple equations. We have x square minus 4 is equal to 0. And now we have to solve it, means find the roots of this equations. So roots of these equations will be plus or minus 2, means solution of this equation. Okay. And when we replace 2 in this place of x, we'll get answer is 0. And when we replace minus 2 in place of the x, we'll get answer is also 0. Okay. So the represent the values of x makes the fx equal to 0, and we can define the roots of an equations as the value of x that makes fx equal to 0. Okay. And the roots are also known as the zeros of the equation. And for quadratic formula, okay, quadratic equations with the form of ax square plus bx plus c. So how we can solve it? Okay, by which formula we can derive the answer of this equation? So we have one, it's standard formula, that is minus b plus or minus square root of delta divided by 2a, where delta is equal to b square minus 4s. Okay, you can use this formula for quadratic equations. Okay, and in place of these equations, we have the equations in this form as a x square plus sine x, okay, is equal to 0. Otherwise, e raised to x plus sine cos x is equal to 0. So for this type of equations, we cannot use this formula. Okay, we cannot derive the delta, and we cannot find x as a by using the formula minus b plus minus root delta divided by 2a. Okay, so for this type of equations, numerical method will help to identify the roots, means identify the solution of this equation. Okay, and here we cannot find the exact answer of these equations, of any equations. Okay, by using numerical method, we can find this approximate solutions of this any equations by using numericals method. Okay, in the roots of equation section, in the interpolations, either it is in curve fitting, we can derive just approximate solution. So the roots or the solution of equations fx equal to 0 are the values of x for which the equations hold true. Okay, means by for x equal to 2, x square minus 4 will become a 0. Okay, so for which value of x equations become a true. Okay, so this is called a solution of this equation. That is called roots of this equation. And numericals method for finding the roots of equations can often easily be programmed. Okay, we can use it there to solve any types of equations, and we can derive it approximate answer by using the uh, numerical analysis method. And now next, there are two types of equations we have. One is the algebraic equation, and second one is the transcendental equation. Okay, what is the difference between these two? equations of the form with degree n. Okay, means one types of polynomial you have as x square minus 2x plus 1, x square minus 4 equal to 0, or x cube plus 5x plus 1. Okay, any equations you can create here. It is involves such degree. Okay, x cube, the degree is 3. Here degree is a 2 in this both equations. So equations of the form with degree n is called the algebraic equation. Okay, for example, fx is can be defined as a0 x raised to n plus a1 x raised to n minus 1 plus up to an is equal to 0. So equations this form this called the algebraic equation, and the non-algebraic equations that we will call transcendental equations, means which involve such trigonometry term, such exponential term, okay, logarithmic term. Okay, we can also consider equation as a x square plus log x. So that is also one transcendental equation. Okay, so if any equation involves such trigonometric term, okay, any exponential term, either any logarithmic term, so this type of equations will is known as a transcendental equation. Okay, and this equation, algebraic equations, we can solve easily that by using the formula of, if it is a quadratic equation, then we can easily solve by using the formula of check a direct output. Okay, here x square minus 4, we can easily say that x is equal to plus or minus 2 is the answer. Okay, but for x minus sin x, we cannot predict such x where functions become a 0. Okay, okay, for which value of x that we replace here and it will become a 0, that we cannot directly predict. Okay, so how we can predict this answer, how we can check its approximate solution? Okay, so the numerical method will help to solve such type of equation. Okay, and now next is intermediate value theorem. What is this theorem? Let us check it. We have one continuous function. Okay, means for x square minus 4 e raised to x sine x. So these are the continuous functions we have. So if fx is a continuous function, and now you have to assume the two value, okay, as a and b, such that f of a is a negative and f of b is a positive. Okay, either you can also consider this condition, okay, f of a is a positive and f of b is the negative. Okay, you can use any one on this both. Okay, fx is given functions which is a continuous functions. Okay, and now you have to assume the two value, okay, a and b, and you can consider ab from the real line. This is a infinite set you have, you can consider any two value from the real line, and now check the output of the functions at a and b. Okay, such that f of a should be the negative and f of b should be the positive. You have to assume the two value from the real line, and now replace this two value. Okay, you have to replace this two value in the functions and check it output. Okay, output should be f of a की वैल्यू नेगेटिव होनी चाहिए and f of b की वैल्यू पॉजिटिव होनी चाहिए. ठीक है, either you can also use this conditions, f of a positive and f of b is a negative. So what is the product of this one? The product of this both value should be the negative. Okay, means f of a into f of b will be the negative output. Why it is negative? Because one output is negative here and second output is positive. Let us take a 5. So minus 1 into 5, that will be the minus 5. Okay, let us take minus 2 into 3, so it will be the minus 6. So we'll get a negative output here. So f of a into f of b will be the negative. Okay, and now we have this interval a and b where f of a is a negative and f of b is a positive, contain at least one root. Okay, by using IVT theorem, means intermediate value theorem, you can say that, okay, in the interval a and b there exists a one root, okay, such that f of x become a 0. Okay, so there exists a one values in the interval a and b such that f of c will be the 0. And what is meaning of f of c will be the 0? The c is called the roots of this equation. Okay, c is known as the solution of these equations. Why it is solution? Because at a c, okay, at x equal to c, functions become a 0. Therefore we can say that c is the answer, c is the roots of this equation. Okay, so this is called IVT theorem. Fx is given equations, and now you have to check, you have to assume the two value a and b. Okay, where f of a is a negative, f of b is a positive. Clear? And now we can say that, okay, one statement. What is this statement? Okay, there exists one root, there exists one value in the interval a and b such that f of x will be the 0. Okay, so What does it mean? That there is one arbitrary value c in this interval AB such that f of c is equal to the 0. Okay, and you can also predict by using this graph. Okay, here fx is a given functions. Let us consider this fx, graph of the fx, and at a b, okay, at a and b, at a functions is negative, okay, that is a positive y, it is a negative y, clear? So let us consider this is a f of a, okay, at the point a, f of a is a negative, at the point b, this f of a is a positive, clear? So this is our range a and b, and which value we have to derive this, our required answer. Okay, this point is our required answer because at that point functions become a zero. Okay, so this is meaning of this intermediate value theorem. You predict one interval a and b where f of a is a negative, f of b is a positive. Okay, so where the graph is intersect on x-axis. Okay, this is our required answer. This point will be our required answer. Okay, so this we have to derive by using such method, by using bisection method, by using false position, and by using NR method. So is it clear to everyone? Is there any doubt in this intermediate value theorem? So you can ask me. Have you any questions? Okay. So
Sir, your voice is reaching.
Sir, your voice is not coming. Sir,
uh,
sir,
now
Sir, your voice is lagging. Sir,
hello everyone. Now is it okay?
yes,
yes,
sir.
sir.
Okay, thank you. Okay, thank you, thank you. Let's start the first method of this unit, a bisection method. So how we can apply bisection method to derive roots of any equation? Any equation, you can consider any types of equations, and you can use this method to find the approximate solution of this equation. Okay, so for a given function fx, okay, any function you can consider, any types of equation you can consider in place of that. And the first step, you have to find one interval ab, okay, such that f of a is a negative and f of b is a positive. Okay, you have to predict such two value, okay, from the real line. You can start with 0, 1, 2, 3, 4, 5, 6, and so on, and put the 0 in the function and check it output. Okay, then after put 1 in the function, check it output, then after put 2, 3, 4, 5, 6, any value you can predict that. Okay, and check the output of functions. So find the two value from the real line as a and b such that f of a should be the negative and f of b should be the positive. एक वैल्यू आपको पॉजिटिव डिफाइन करनी है, ठीक है, मीन्स फंक्शन का आउटपुट पॉजिटिव होना चाहिए, एंड सेकंड वैल्यू you have to consider from the real line which output should be the negative. Okay, this is the first step to implement the bisection method. Consider the fx that is already given in the question, and then after you have to predict one interval a b such that f of a is a negative and f of b is a positive. Okay, that is easy task. And then according to IVT, means intermediate value theorem, the interval contain at least one root in this a and b. Okay, this interval you have where f of a is a negative, f of b is a positive. So by using the IVT theorem, okay, we can say that okay, there exists one root, okay, in this interval, and that is our required answer. We have to find out that. So how we can find
Can
this
you
root?
repeat this?
Yes, Subham.
Sir, can you repeat the root between A and B? What you last said? I don't understand.
Okay, let us repeat. Okay. Okay, yes. Fx is a given equation, okay, in this question. And our task is find the roots of this equation by using the bisection method. So in the first step, you have to predict one interval, okay, where f of a is a negative and f of b is a positive. Okay, you have to predict such two value from the real line. Okay, there is infinite values we have. And you can consider any value and check it output. If it is a negative, then you can consider it is a value a. Okay, and use the another value from the real line and check it output if it is a positive, and you can consider this value as a b. Okay, so consider this interval ab. Okay, and by using the IVT, okay, what is meaning of intermediate value theorem? If we have such interval ab where f of a is a negative and f of b is a positive, so we can say that this interval contain one root, okay, of the given equation. So now we have to check this root. So how we can check this root? By using bisection method. So in the first approximation, how we can check the first approximate answer in the bisection method? That is called x1. Okay, how we can predict x1? So just consider average value of the a and b. Okay, a plus b by 2. This is your first approximation of the equation, first approximate answer of the given equation. Okay, consider it average value a plus b by 2. Okay, now in the next step, check the function output at the x1. Okay, means fx is given and replace x by x1 to this equation and check it output. If it is a zero, okay, there is two possibility, either it is zero, otherwise a non-zero. Okay, so if it is a zero, then x1 will be the roots of the equation. Okay, x1 is called the required answer. X1 will be the roots of this equation. Clear? And if it is a non-zero, suppose कि उसकी value non-zero define होती है, so there is a two possibility for the non-zero case. Okay, either it is negative, okay, otherwise it is a positive. Okay, if it is a non-zero case, so how, what is the possibility answer, possible answer there? It is will be the non-zero, otherwise means it is a less than zero, otherwise greater than zero. It is positive, either negative. Clear? So how we can define, okay, the next iterations if it is a negative answer? Okay, means if f of x1 is a negative, then roots lies in between x1 to b. Okay, means in this formations. The first iteration is the number of iterations. The first iteration value of a where f of a is a negative and f of b is a positive.
Sir, voice is lagging again. Sir, sir,
Sir,
sir,
sir, your voice is
voice is
not
not
coming.
clear.
F of a is a negative.
Sir, your voice not audible.
Sir, sir,
Yes, hello. Now am I audible?
Yes, sir.
Yes, sir.
Okay, okay,
Yes, sir.
okay. There is a network
Yes,
issue in
sir.
mobile. So network. Okay, so we are discussing about the roots of equations by using the bisection method. Okay, so first find the interval AB, okay, and then check the first approximate answer by using the formula A plus B by 2, okay. So we'll get x1 by using the formula A plus B by 2, and now check f of x1. If it is 0, then it is our answer, okay. If it is a non-zero, then there is a two possibility that, okay, it is negative, either it is a positive. So what we'll do in the negative case, okay, if it is a negative, then in the second iteration, means in second approximate answer, in second root, how we can modify the data, okay, means how we can change the interval A and B. So if it is a negative, okay, suppose f of x1 is a negative here, then this x1 will be replaced to the negative point, okay. What is our negative point? Here A is the negative point because f of A is a negative, clear. So we'll replace this x1 to the place of A, and we'll consider B is as it is here, okay. And in the second iteration, the formula will be for x2, that is a x1 plus B by 2, clear. How we can check, how we can consider here x1 in place of A? Why it is happen? Because here f of x1 is a negative, okay. So in the second iteration, second approximate answer will replace this A by x1, okay. So we'll get a new interval x1 to B, okay. And to find the second iterations, use the x2 as a x1 plus B by 2, clear. And either it is, if it is a positive, suppose f of x1 gets a positive answer here, so will our interval will be we'll consider this x1, okay. We'll consider this x1 as a we'll replace this x1 in place of B, so x1 will consider here, and A will be as it is that, okay. So x2 formula will be the A plus x1 divided by 2, okay. And continue this process up to the required answer, okay. Means how many iteration is required, which is mentioned in the questions. It is x1, x2, x3, x4, and so on. So this procedure is simple that, okay, first check the A and B, and then find the x1, then after check f of x1. If it is a 0, then it is our required answer. If it is a non-zero, then in the second case, okay, just replace this x1 to the negative point, means we'll replace this x1 to the A, okay, and the new interval will be the x1 and B, clear. And if it is a positive, then we'll replace this x1 to the B. A will be stay as it is there, A to x1, okay, and then x2 will be A plus x1 by 2. And now check for f of x2. If it is a negative, then replace this x2 to the negative point. And if it is a positive, replace this x2 to the positive point. Clear? Now, is there any doubt in this method? Is it clear to all? Have you any questions?
No, sir.
Okay, good. Remaining student, have you any doubt, any query? Oh, good. So in this particular, suppose f of x1 is a negative, then roots lies in between x1 and b, okay. And again bisect that, okay. Again we have to take the average of this both value. So it will be x1 plus b by 2, okay. And then after check f of x2. If it is a negative, then x2 will be replaced to the negative point, okay. And if f of x2 is a positive, then x2 will be replaced to the positive point, clear. And again bisect to identify x3, x4, x5, x6, and so on. So repeat this procedure to generate the x1, x2, x3, x4 till the roots up to the desired accuracy is obtained. Clear? Which is mentioned in the questions. How many roots is required for these questions? Okay, that already given in the questions. Okay, how many iterations we have to derive to check the answer? Okay, and this graph is given here. Here A and B 2 point is mentioned arbitrary, that is a x, and it is a positive y, that is negative y. And at point A, f of A is a negative, this is a negative y here. And at B, f of B is a positive. Okay, and this is one graph of the fx, and we have to predict this value. Okay, हमें ये value predict करनी है. So first consider it average A plus B by 2. So get x1, check f of x1. If it is positive, okay, then roots lies in between. Will replace B by x1, okay. So now this size, this interval is decreasing, okay. and that is a2 x1. Again, consider it average, find the x2. Okay, check f of x2. If it is a negative, then again this size will decrease that. Okay, and you can reach to your required answer. Okay, so this is called a bisection method. And now let us implement to this in the first example. The equation is there: x cube minus x minus 11 is equal to 0. Okay, fx is given that x cube minus 11 x cube minus x minus 11 is equal to 0, and that is not quadratic equation, so we cannot apply here minus b plus root delta divided by 2a, because what is the degree? Degree is equal to 3. Okay, so this contains the 3 different type of root, but by using bisection method we can predict one root there. So how we can predict this root? Let us check that. Fx is given. Okay, first you have to mention it here, and now this is important for all. Okay, use the radian mode in your calculator, in your scientific calculator, for the solution of any example of the numerical method. Okay, for solution of any example of numericals method. And how many of you have scientific calculator right now? In the last lecture I said about the LC calculator. Okay, so in this calculator, how we can convert to the radian mode? Okay, so in this top of the corner there is a mode button is given that. Okay, just press it. So there will be three option will be display. Okay, gradient, then after radian and the degree. Okay, and just press the 2. Okay, suitable option of the radian. Okay, and then you can see that in this your screen that is a radian mode. Okay, R will be display in your screen. So if you have any query, then you can ask me how we can convert a calculator in the radian mode. Okay. So first check the this radian mode. Okay, in your calc, and then after you can start to find out the interval AB and rest of all the data. Okay. So now first find the interval AB where f of a is a negative and f of b is a positive. Okay, f of a is a negative and f of b is a positive. So you can consider from the real line, first consider the perfect value. Okay, 0, 1, 2, 3 and so on. So equation is x cube minus x minus 11. So when we replace a 0, let us start with the 0 there. So what is answer of f of 0? F of 0 is equal to the 0 minus 11. So it will be the minus 11. Okay, then after f of 1, okay, next perfect value is a 1. So what is f of 1? That is also minus 11, because 1 cube minus 1 minus 11. Okay, so 1 minus 1 will be neglected, remaining is minus 11. So it is also minus 11. Okay, then after f of 2, we need one interval where for this point functions negative and for the second point functions positive. So what is answer of f of 2? So that will be the 8 minus 2 minus 11. Okay, and what is answer of 8 minus 2 minus 11? That will be the minus 5. Clear? So it is a negative. And what is answer of f of 3? That will be the 27. Okay, 8 cube will be 27 minus 3 minus 11. Okay, so that will be the 13. So 13 is positive. Clear? So here at a 2, f of 2 is a negative, and at a 3, f of 3 is a positive. Okay, so we can say that our required interval, okay, that is 2 and 3. Clear? So our roots lies in between, the required roots lies in between 2 and 3. This is your first step to check the bisection method. Clear? This is the first step to verify, to apply the bisection method. Find the interval AB. Okay, where f of a is a negative, f of b is a positive. Clear? And now in next step, you have to prepare one table, okay, to derive a required answer. So in the first column, mention the number of iterations. Okay, 1, 2, 3, 4, 5 and so on. And in the question it is given that how many iteration is required. Okay, so a bisection method up to the fourth approximation. Fourth approximation means there is a 4 iteration is required: x1, x2, x3 and x4. So x4 is our required answer. Okay, if it is given 5 iteration, then you have to derive the 5 roots, 5 answer: x1, x2, x3, x4 and x5. Okay, then after, if it is given up to the 6th iteration, 6th approximation, then x6 will be our answer. Okay, here x4 will be our answer in this case. So there is a 4 iteration is required. Okay, second column, consider value of a, where f of a is a negative. Then after value of b, where f of b is a positive, then formula of bisection, that is a plus b by 2, and then after the function output f of xn. Okay, so in the first step, in the first iteration, use the value of a and b. So a is a 2, where f of a is negative, and b is a 3, where f of b is a positive. Okay, and in x1 it will be the 2 plus 3 by 2. Okay, uh, that will be the 5 by 2, and 5 by 2 will be 2.5. Okay, this is your first approximate answer. Okay, 2.5. Clear? And now in next step, check the function output, means replace the 2.5 to the x. Okay, so it will be the we have function is x cube minus x minus 11. This is our function. So replace the 2.5 to the x. So 2.5 cube minus 2.5 minus 11. So now you have the Kelsey. So check it. What is the answer? 2.5 cube minus 2.5 minus 11. Okay, just use the simple Kelsey and just type the data. Okay, 2.5 cube minus 2.5 minus 11. Okay, so what is this answer? 2.125. Is it getting to all is or not?
Yes.
Okay, good. Okay, so function output at the 2.5, that is equal to 2.125. Okay, so what is the nature of this? It is a positive. Clear? 2.125, that is a positive answer. So in the second iterations, we'll modify our interval. Okay, and how we can modify our interval? अगर ये पॉजिटिव वैल्यू है, ठीक है, if it is a positive, then replace this 2.5 to the positive point. So what is our positive point? B, because f of b is a positive. Okay, so here 3 will be replaced by 2.5. Okay, and here 2 will be as it is. Clear? And again derive the x2 by using the average of the new interval. Okay, so 2 plus 2.5 divided by 2. And what is the answer of 2 plus 2.5? That will be the 2.25. Okay, so here will be the 2.25. You can just verify it by using your calculator. Okay, so 2.25, and now check the 2.25 output. Clear? To the function. So replace 2.25 in this data. Okay, so here we have 2.25 cube minus 2.25. Okay, minus 11. Okay, so just derive the answer. That will be a minus 1.8593. Is it correct or not? Everyone get this answer? Minus 2 point.
Sir.
Yes. Yes. Any questions? Okay.
Sir,
Yes. Yes. Speak.
in how many iterations we have to repeat this process?
Up to the fourth iteration. That is mentioned in the question. Let us just check it again. Just 1 minute. CPT is loading. Okay, so that is mentioned in the questions. Okay, apply this bisection method. Okay, for this equation up to the fourth approximation. Fourth approximation means x1 is the first approximate answer. Okay, then after x2 is the second approximate answer, x3 is the third one, and x4 is the fourth one. Okay, up to the fourth approximation. Okay, so that is a meaning of this one. And now check f of 2.5. So what is the answer of f of 2.5? That is a 2.25 cube minus 2.25 minus 11. Okay, so just check it and you can see, and we get answer is minus 1.8593. 8593. Okay, so it is a negative answer. Okay, we get f of 2.5, that is a negative output. Clear? So what we'll do in the third iterations, we'll replace this 2.25 to the negative point. And what is our negative point? 2 is the negative because f of a is a negative here. So replace this 2 by 2.25 here, and here 2.5 as it. Okay, in the third iteration, how we can, what is the meaning of this? Okay, here 2.25 is the negative output. Okay, so in the next iterations, we will modify our interval. Okay, so here 2.25 will be replaced to the 2. Why it is a 2? Because f of 2 is the negative. Okay, so therefore we replace this negative point to the negative output. Okay, and here 2.5 as it is. And now in x3, that will be a 2.25 plus a 2.5 divided by 2. And just check it output. That will be the 2.375. Okay, here we'll get 2.375. That is the average of this one. And then after check the f of 2.375. Okay, x cube minus x minus 11. And then after check 2.375. So what is the output of 2.375? 2.375 cube minus 2.375 minus 11. So that will be
0.0021484.
yes, good. That is 0.02148. Okay, so it is positive. So we'll replace this 2.375 to the positive point. That is a 2.5. That is next interval, and here 2.25 is it. Okay, so just check the x4. X4 will be 2.25 plus 2.375 divided by 2, and when we take its average, we'll get a 2.3125. Okay, and that is our required answer. Clear? Function output is our not answer. Okay, what will be the function's output there? This x1, x2, x3, x4, this is our required answer. Okay, that is the first approximation, that is the second one, that is the third one, and there is a fourth one. And you can also check that, okay, why it is approximate answer. Okay, why we cannot consider it is a perfect answer. When we say perfect answer, at any x, okay, at any value of the x, if fx become a 0, then this x is called the perfect answer. Okay, it is called exact solution. But here you can check that at f of 2.5, we get answer is 2.125. That is not nearer to the 0. Okay, it is not a 0 there, and it's also not nearer to the 0. Then after it, a 2.25, function output is minus 1.8593. It is also nearer to the 0. Okay, not nearer to the 0. Then at 2.375, we get answer is 0.2148. And we can consider it is nearer to the 0. Okay, because we get 0.0 something value. Okay, and when we check f of 2.3125, we again get a closer answer. Okay, nearer to the 0. Closer answer to the 0. And therefore we can consider that is a approximate answer. Okay, you can predict just approximate answer by using any method in numerical analysis. Clear? Because sometimes we required only just approximate solutions. Okay, what will be the solutions? Okay, for this given model. Okay, mathematical model. So therefore in this case we can use such type of method to predict just approximate answer only. Okay, not exact solution. And sometimes there is no any exact solution is required. So in such case we can use such type of method to predict that. So is it clear to everyone? Is there any doubt in this example? So you can ask me
सर
right
तो उसका मतलब वो ना कि जो पहले x का जो आंसर होगा उसके
now.
आस करीब का आंसर होना चाहिए, वही अपना
Yes,
जो मेन
yes,
आंसर
yes,
होगा,
yes, yes,
राइट?
yes, yes. Okay,
ओके.
that is a first approximate answer. Okay, you can consider it is
गॉट
one
इट,
type
गॉट
of solution. Okay, you can consider 2.5 as a one types of solution. Okay, but you have to consider up to the fourth approximation, fifth approximation. So you can modify it. Okay, as up to the your possible required answer.
तो
Okay?
सर वो आंसर जब तक नहीं आता तब तक चलते जाने का ना,
हाँ,
x
yes,
x
yes,
लेके.
yes. तब
ओके,
तक चलते जाना. ठीक है. Right now it is contain only 4 iterations, but when we consider when we check the next or next to next example, it will it involves the 11 approximations there. Okay, to find the required accuracy. So now any doubt to anyone? Okay, so this is a solution of this one 2 3, then it is a 2.5, and that is output of this one, then replace 2.5 to the 3 because it is positive. So 2 and 2.5 is our new interval. Find x2, 2.25, and check it output minus 1.8593. Again replace the 2.25 to the 2 because it is negative. Again take it average, so it is 2.375, and check it output, and it is positive. So replace 2.375 here to the positive point. Again consider it average. So we get a required answer 2.3125. Okay, so let us with the new questions. It involves some trigonometric term. Perform the 5 iteration of the bisection method to obtain the roots of the equations cos x minus x e raised to x is equal to 0. Okay, and we can easily say that okay, we cannot predict the direct answer. Okay, for which value of the x of the real line where f of x become a 0. Okay, so how we can check it answer? So let us implement this method. Fx is cos x minus x e raised to x is equal to 0. And now first find the interval AB where f of a is a negative, f of b is a positive. Okay, so here first put x is equal to 0. Okay, and first check that calculator should be in radian mode. Okay, we cannot consider answer of any trigonometric term in degree mode. Okay, so consider it radian mode, and then after check it output. Okay, there is no any problem in polynomial case. Okay, answer of any polynomial will be same in degree as well as radian, but for trigonometric term, okay, you first check your calculator in radian mode, and then after check the output of AB and function. So at x equal to 0, okay, functions output that will be the 1, and you can easily check that. Okay, that should be the radian mode. And now let us consider a value of cos at the 0, cos 0 minus x into e raised to x. This is our function, so 0 into e raised to x, that is e. And in your calculator just directly mention here 0. Okay, because it will be in the form of e raised to 0 case. Okay, in this scientific Casio calci, and there is no any required for this k. Okay, but in this calculator this is required, so therefore I mention it this k. And now the output is a 1. Okay, in calci directly you just mention this form. Okay, there is no any required this cap e raised to 0 form. Okay, just type this form in your calculator and you can check that answer is a 1. Okay? But here it is in calci, it is required this cap, so therefore I mention it here. Okay, the answer is 1. So f of 0 is a 1. This is positive, so we can consider this is a value of b. Okay, because f of b is a positive here, so b is equal to 0. And now next point, that is a 1. So use x is equal to 1 in this equation and check the output. That will be the minus 2 point something. Okay, let us check that. So here in place of 0 you have to put 1. Replace 1, then it is 1. Okay, then e raised to 0, that is e raised to 1. Okay, cos x minus x e raised to x. So now output that will be minus 2.17. Okay, 1797 and so on. So it will consider minus 2.1780 and so on. Okay, round of value. So this is the output of this equation at x is equal to 1. Okay, and it is a negative, so we can consider this value as a is equal to 1. Okay, so f of 0 is a 1, so we can consider is a positive, therefore b is equal to 0. And f of 1, that is minus 2.1780, and therefore we can consider as a. Okay, so our interval, that is a 1 0. Okay, where 1 at the point 1 f of a is a negative, f of x is a negative, and at 0 f of 0 is a positive. Okay, so roots lies in between 1 and 0. Clear? And now let us check the answer. Here we require the 5 iterations: x1, x2, x3, x4, and x5. Okay, so here at a, okay, that is a 1 here, and b, that is a 0. Okay, at 1 0, so x1 will be 1 plus 0 by 2, and that will be 1 by 2, so it is a 0.5. Okay, so check f of 0.5. Okay, check the f of 0.5. So you will get answer is a consider 0.5 in place of 1. Okay, consider 0.5 in place of 1, that is 0.5. Then after 0.5 and e raised to 0, that is 0.5. Okay, and then after enter, answer will be 0.0532. Are you getting this answer or not? 0.0532, that is f of 0.5.
No, sir.
Yes, why it is not? How many of you get this answer? F of 0.5, that is 0.0532. Okay, in your calculator, first check the radian mode. Okay, then after type in this form. Cos पहले type करना है, ठीक है? Then after use the bracket 0.5. Okay, cos 0.5 minus 0.5. Then after consider shift E. Okay, shift ln उसमें option होगा shift ln. Then you can use the E option. Okay, exponential option. Then use shift ln, use the E. Okay, and then after directly mention the value here. Okay, 0.5. There is no any required the cap. Okay, in this calculator is required a cap to predict the answer of e raised to x form. But in your calc it is you can check directly by putting directly the value. Okay, after the E. So E of 0.5, and then you will get our answer 0.0532. Shubham, is it now okay? Are you getting this answer? Shubham, Syam? Okay, good. Okay, so this is a positive value. So in the next iterations, we'll change this interval. If it is a positive, then 0 will be replaced by 0.5 and here 1 as it is. Okay, so in the x2, find the average of 1 plus 0.5 by 2, that is a 1.5 by 2, and that will be the 0.75. Okay, so now check the answer of f of 0.75. F of 0.75, and that will be consider 0.75. 75, and it is 75 and 75. Okay. And then use the enter, you will get a negative output minus 0.8560. Okay, here will be minus 0.8560, that is a negative. Is it okay? Clear? So if it is negative, we'll replace 1 by 0.75. Okay, and here 0.5 as it is in x3. Use again the average. It will be 0.75 plus 0.5. Okay, 0.75 plus 0.5 divided by 2, and that will be 0.625. Okay, divided by 2, average of these two. So now check f of 0.625, and what is the answer of 625? Let us check. 0.625, that is required. To 5. Okay, and it is also 625, and the last e raised to the power, that is also 625. Okay, now take the answer, that will be the negative. Okay, again negative, minus 35 666. Okay, minus 356. So f of 0.625, that is minus 0.3566. Okay, that is negative again. So replace 625 in place of 0.75 in the fourth iteration, and here 0.5 as it is. Okay, now check export by taking averaging of this both value, and you will get average value, that is minus 5625. Okay, 0.5625, that is the average of this both. And now check function output 5625. So answer of this one will be, consider 5625 in the x out values. Okay, so here it is 5625, 5625, and is 5625. Okay, and power of e raised to 0, that is 5625. Okay, so output will be again still negative. Okay, we get minus 1.41, minus 1.41 something. Okay, so f of 5625, that is minus 1.4113, 13, that is again still negative. So in x4 again we'll replace 625 by 5625, and here 0.5 as it is, and in x4, that x5, that is our final answer, and the average of this both, that will be minus 53125. Okay, so answer of this one, that is 0.5312 Okay, that is the fifth iteration answer, and that is our required answer. Okay, so this is actual table for a 1 0. X1 is a 0.5 and f of x1 is 0.532. Okay, if it is positive, replace 1, 0 by 0.5, use the new interval 1 and 0.5. X2 will be 0.75. Okay, check f of x2, it is negative, so 0.75 will be replaced to the 1, and new interval will be 0.75 to 0.5. So this is x3, use the average, and f of x3, that is a negative, so 0.1625 will be replaced to here. Okay, 0.5 as it is, again take it average, the x4, and check f of x4, that is still negative, so replace x4 to the in the fifth iterations 5625, and that is 0.5 as it is, and use it average, that is a required solution. Okay, up to the 5 iteration, means 1 2 3 4
Sir,
5. Yes.
so what is the like real time application of this method?
Okay, you can predict the roots, okay, for any mathematical modeling equations. Okay, how we can check the roots for which value of the x functions satisfy. Okay, so you can predict this answer if any method, any mathematical model required so solutions. Okay, just need approximate solutions of the given mathematical model equation. So how we can predict that? Okay, how we can check it? So this method will helpful there to predict your answer.
Okay, sir.
Okay, so now it is clear to all. Have you any doubt? So you can ask me. So you can resolve it. Otherwise, we'll take the attendance and then we'll conclude the session.